capacitance. So I've divided this capacitance chapter in two parts. First is capacitance 1 part, and second capacitance 2 part, basically, where we'll discuss few questions. So till now, guys, in class 12th, you guys must have studied, or there a session based on electrostat, current, electricity. Now this capacitance. Hello Yash, Rohan, how are you everyone? So first is need of capacitance. So you can expect at least one question in JEE mains related with capacitance and in advance as well. So this capacitor chapter is very, very important. So let's start with this is IIT JEE main 2015 question, right? Here it is given that in this question, hello Siddhi, in the given circuit, charge Q2 on the 2 microfarad capacitor, right? So this is 2 microfarad capacitor. Changes as C varies from 1 microfarad to 3 microfarad. Means this is C and its value is changing from 1 microfarad to 3 microfarad. Now, Q2 as a function of C, Q2 as a function of C is represented by. So to solve such type of question, basically this type of circuit is very common. I'm drawing this circuit first and then explain. So this circuit is basically combination of 3 capacitor like this. And some voltage is being applied here. Now the question is, hello Abdul, Mohini. I can see everyone's chat. So what store capacitors? So actually capacitor stores charge, right? So we are studying, don't worry, we'll have few questions of JEE mains. We are discussing this question. Now this is C, right? And this one, 2 capacitors, so its value is given. I'm just taking 1 microfarad and 2 microfarad. This is 1 microfarad and this is 2 microfarad. Okay, now if we change C, my question is, guys, if we change C, right? So charge on this capacitor, I'm showing you, will it change or remain constant? So obviously it will change. It will change. So let's obtain some voltage relationship, because voltage relationship is very important. To solve such type of circuit, we all know 1 microfarad capacitor and 2 microfarad capacitor. These two are in parallel. So voltage remains same. Micro means 10 to the power minus 6, right? So these two in parallel. So we can say that this is like this capacitor and its equivalent capacitor. This is C, and we can say this is 3 microfarad capacitor, and this is voltage applied here. To analyze this thing in a better way, okay, so what we can say here from this diagram part, this is E applied, what a EMF, it is given in this question. See, this is E value given. Now this is E, this is C, and this is 3 microfarad. Remember the concept of resistor, because it's very easy to analyze with the help of resistor here. If we have a resistor and this is a voltage, question is, what will be the voltage across R2? This is my question. So we can directly apply voltage division. This is JEE session, Abdul. This is a question I've taken based on JEE mains. So voltage across R2, we can directly write this expression. This is equal to R2 upon R1 plus R2 multiplied by supplied voltage E. This is E, right? This is in terms of resistor. Here we have capacitor. Here we have capacitor. So we can write capacitor voltage, but just opposite to resistor. Means we have to take different arm. For example, here I'm writing voltage across 3 microfarad capacitor. This is equal to, this will be C upon C plus 3. All I have taken in micro. So we can say this is C upon C plus 3 into E. So this is a way we can obtain voltage directly, right? This is class 12 question. Hello, Shikesh. So we can obtain voltage. Why we are obtaining voltage? Because once we know voltage, so voltage across 1 microfarad capacitor and voltage across 2 microfarad will remain same. So we can obtain charge on 2 microfarad capacitor, and by obtaining charge, we can obtain particular relation. So we have to choose this option, this option. So basically we have 4 options, right? So now 3 microfarad capacitor. So V3 C upon C plus 3 E. Next is charge. Charge on 2 microfarad capacitor. So we know the expression for charge, which is very easy. Q is equal to CV. But here we want to obtain charge on which capacitor? This capacitor, 2 microfarad capacitor. So C will be 2 microfarad into voltage. We have obtained this voltage. That voltage is C upon C plus 3 into E. C upon C plus 3 into E. So this is the expression for charge on 2 microfarad capacitor. This is expression. But the question is, we have to check which one is correct. 4 options, we have to check now. So what we'll do is, we'll obtain its slope here. See, this will be its slope. Here also, this will be its slope. Right now, and slope is what? So here slope is changing. So basically we have to obtain the dq2 upon dc, right? And we'll see that its slope is increasing or decreasing. Based on that, we'll choose options A, B, C, and D, right? So coming to the slope part, how to obtain slope? So we'll have to differentiate dq with respect to dc, because dq upon dc, see, there's a slope because this graph is between q and c, right? So I'm differentiating this. This is equal to 2e, taking LCM, c plus e whole square, c plus e minus c. So what we'll get? We'll get 6e by c plus e whole square. Okay, so this is dq by dc. dq by dc. Basically, this is dq2, means charge across 2 microfarad capacitor. Now the question is, if c is increasing, obviously dq2 by dc is a slope. Slope will decrease. So in this here, option A, option B, option C, because we'll not take option number D, because here charge is decreasing. Here charge is decreasing, but in actual, charge will increase. How charge will increase? See the circuit diagram here. 1 microfarad, 2 microfarad, this is capacitor, right? So we can say here charge Q equal to CV, means if V is increasing, Q will also increase. Here C is given. So we have formula Q equal to CV. So we can say that V is equal to Q by C. So from here, we can say that if C is increasing, voltage across this C is decreasing. So here voltage is decreasing. So definitely here voltage will increase, because net voltage supplied is constant. So here voltage decreasing, here voltage increasing, so charge will increase. So D option cannot be answer. So we have to check A, B, and C. So now out of A, B, and C, in which case slope is decreasing. See, slope is decreasing. So now here we'll take point here, we'll take another point I'm showing you. So if you see option number B, guys, please respond. Option number B, slope is increasing or decreasing in option number B? Tell me. In option number B, slope is increasing or decreasing? Guys, please respond. So in B, slope is decreasing, right? That's why correct option is option number B. Here, if we take this point, now, so see, slope is increasing. So B is correct option. Now moving next. I hope this question is clear to everyone. Now this question. Again, this is JEE Main 2014 question. A parallel plate capacitor is made of 2 circular plates separated by a distance of 5 millimeter. So here capacitor is in circular shape like this. Okay. and its distance given as 5 millimeter. This is 5 mm. With a dielectric constant 2.2. So some dielectric is inserted here. So this is dielectric, let's suppose, inserted. Its value is given as 2.2. Between them, when the electric field in the dielectric is okay. So this electric field is given. Electric field is given as electric field is given as 3 into 10 to the power 4 volt per meter. The charge density of the positive plate will be close to. Okay, Ajinkya. But here this is capacitor, so please attend this session. This is based on capacitor. Now, guys, see electric field given. So you need to be very careful that is it net electric field or maximum electric field. So we have to check this thing. In this situation, when the electric field in the dielectric is 3 into 10 power 4 volt per meter. So basically this is net electric field of this dielectric. So we know that electric field formula E net is equal to E naught by K times, because this is the effect of dielectric, that once we are introducing dielectric, now electric field becomes 1 by K times. So E naught upon K. So E net given 3 into 10 power 4. K given, we can obtain E naught. E naught is electric field between the two circular plate or any plate, parallel plate, basically parallel plate capacitor. So we can say that E naught is equal to E net. E net is how much? This is E net. This is E net. So this is equal to 3 into 10 to the power 4 into K. And what is the value of K? K, it is given dielectric constant, and here dielectric constant is 2.2. So we can say this is equal to 3 into 10 to the power 4 into 2.2. So this is E naught, fine. Now if we have capacitor plate, and between electric field value, we all know this value is equal to sigma upon epsilon naught. Actually, basically sigma upon 2 epsilon naught. Since it is having two plates, so sigma upon 2 epsilon naught plus sigma upon 2 epsilon naught. So it comes out as sigma upon epsilon naught. So this is sigma upon epsilon naught. So electric field we have obtained, calculated. So we can say 3 into 10 to the power 4 into 2.2 is equal to sigma. Sigma is what? Charge density upon epsilon naught. Its value is fixed, 8.85 into 10 to the power minus 12. So from here you can obtain charge density. So if you solve this thing now, you will get option number C. So the correct answer for this question is option number C. Any doubt in this question? So I hope things are fine. Now let's move on to next question. This is JEE advanced question. Guys, once we see the advanced question, we thought that, oh, question must be very difficult. But believe me, this question is very, very easy. Because if once you started solving any question, you have to stick to a few basic things here. Just read the question and we'll try to understand first this question and then we'll try to solve. Here, a parallel plate capacitor has a dielectric slab of dielectric constant K between its plate that covers 1/3 of the area of its plates. Means in this question, it is given that up to this part, I have read this thing. Okay, so its dielectric is filled, but not whole area. This area is just A/3. This area is just A/3. So we can easily say that this area, whole area, will be remaining area. That is, this will be 2A/3. So that if we add these two, net area is A/3 and 2A/3. Okay. The total capacitance of the capacitor is C. Means overall capacitance is C. So if this is C1, if this is C2, so these C1 and C2 is in parallel. And we all know when capacitors are connected in parallel, C equivalent is C1 plus C2 and so on. So here only two capacitors, so we'll say C1 plus C2. We are assuming C1 and C2. Now let's next move on. While that of portion with dielectric in between is C1. Okay, fine. So C1 is already given. So in this expression, this C1 is already given. This C is already given, but C2 is not given. Okay. Now, when the capacitor is charged, now we are charging this capacitor, the plate area covered by the dielectric gets charged Q1. Okay, so this becomes Q1, and the rest of the area gets charged Q2. So this comes Q2 charge. Okay, the electric field in the dielectric is E1. Okay, so this is E1, which is given, and that in the other portion is E2. Okay, this is here E2. Choose the correct option. Okay, ignoring edge effect. Fine. So we have to choose out of 4 options. So whenever you are solving such type of question, it's very easy to obtain relation in terms of capacitor. So let's first solve for option number D, because C1, and we all know when we are inserting capacitor, sorry, dielectric in capacitor, so C nu becomes K time of C. We know this thing. In this situation, we have 2 capacitor. First is filled with dielectric, whose dielectric constant is K as given, and another is not filled with dielectric. So we can say that C equivalent must be C1 plus C2. C equivalent must be equal to C1 plus C2. Now, what about C1? So C1, we can say that formula, standard formula is for C, epsilon naught A by D. This is standard formula. Now here, epsilon naught, since dielectric field, now dielectric is field, so what we can say, it will become K times. So this is K epsilon naught. Fine. Now area is not A this time, area is A by 3. So we have to write A by 3. Area is A by 3, okay, upon D. D, as it is no change in D, so D will remain constant, D. Fine. Simplifying this, so we'll get K by 3 epsilon naught A by D. Right. Now, what about C2? We can easily obtain C2 as well, no? How? C2. C2 is epsilon naught A. A is 2A by 3. 2A by 3. Epsilon naught A, and D is D as it is. So simplifying this, so we'll get 2 by 3 epsilon naught A by D. So this is the value of C2. But in this question, the value of C1 is given. So we can obtain C2 in terms of C1. Why? Because C1 and C is given, C2 is unknown. So let's obtain C2 in terms of C1. Okay, so we can say epsilon naught A by D, its value is 3C1 by K. Means its value, we can replace, if equation 1 now, so we can replace this value from equation number 1. So we can say this is equal to 2 by 3 into, this is 3C1 by K. Okay, so 3 gets cancelled out. This is equal to 2C1 by K. So this is the value of C2. 2C1 by K. Right. Next is, we have to check this relation, D option. D option is C by C1. D option is C by C1. So C upon C1. C upon C1 is, C is what? C equivalent. So we can say C1 plus C2 upon C1. Okay. So C1, 1 plus C2 upon C1, we can say this is equal to 1 plus, the value of C2 is 2C1 by K. And C1, as it is C1, I'm writing C1. Okay, C1 gets cancelled out. So we are getting this as 1 plus 2 by K, which comes out as K plus 2 by K. So option number D is correct. So this was for D option. Okay, so this is D option. Next, this is live. Bimal, this is live session. So C upon C1 is equal to 2 plus K upon K. D option is correct. But this is MCQ multiple correct option. So we have to check A and B. Now electric field and charge. So guys, we know all how to obtain charge and electric field. We have few relation I'm showing you. We want to obtain relation in electric field. We want to obtain relation in charge. How to obtain these relation? So Q is equal to CV, standard formula. And what about electric field. So we can say V1 minus V2 is equal to E dot D, right? So from this, we can conclude that if we are able to calculate V, if we are able to calculate V here also, then we'll able to calculate Q as well as we'll able to calculate E. Okay, let's see the V expression, how to obtain V. In this circuit, how to obtain V. Okay, C1 and C2. Guys, these two are in parallel. And what is the property of parallel? In parallel connection, voltage remains same. Means voltage across C1 is equal to voltage across C2. But we can say that here, voltage across C1, if this is C1 and this is C2. Hello, Shakti. If this is C1 and this is C2, so what we can say that since these two are in parallel, it is filled with dielectric. So C1, C2 parallel, so voltage remain constant. So voltage remain constant. So this is constant term. Now coming to this, E1 by E2 is equal to E1 by E2. Which relation? Either A or B. Okay, so we can say E is equal to V by D. E is equal to V by D. Since voltage, this what? Potential difference. This is same across both the capacitor. So E1 by E2 must be equal to 1. Getting now? Because D is constant in both the situation. V potential difference constant. So net E1 upon E2 is equal to 1. So here out of option A and B, A option is correct. Any doubt? Now moving next, C option. In C, this is Q1 by Q2 is equal to 3 by K. We have to check. Again, we can use this relation Q equal to CV. V remains same. So basically Q1 by Q2 is equal to C1 by C2 because V same. So if you want, you can write VV and VV gets cancelled out. This is equal to C1 by C2. And we already have calculated the C1 and C2. C1 is C1 already given and C2 is 2C1 by K. C1 upon 2C1 by K. Cancel out. So it comes out as K by 2. Let's check this option. So K by 2, no option. This is 3 by K. So not. So the correct options are option number A and D. Any doubt in this question? Very basic conceptual question, not very hard to solve. Okay, now let's move on next question. Okay, this is JEE Advanced 2013 question. We'll try to again understand this. Again, very simple question, a little bit conceptual part here. In this question, it is given that in a circuit shown in the figure, there are two parallel plate capacitors, each of capacitance C. Okay, means it is given that C1 is equal to C2. C1 is equal to C2 and its value is C. It is given. Okay. The switch S1 is present first to fully charge the capacitor C1. Okay. Initially this S1 is connected and then release. So here, if S1 is connected, can I say this C1 will start charging? Because this is open now. Initially this is open. And when we connect the switch, C1 get fully charged. And how much is that Q max? So Q max is C into V. So we can say C into 2V0. Why 2V0? Because here voltage potential is 2V0. So total charge is 2CV0 when S1 is connected. Now question is, we are opening this S1 and we are closing this S2. See, the switch S2 is then pressed to charge the capacitor C2. Okay, right. So what will happen? See, now this is open and we are closing this switch S2 and this is open and its charge is plus 2CV0 plus 2CV0 and this will be minus 2CV0. Okay, now when we just connect this thing now, since C1 is equal to C2, C1 is equal to C2, what will happen? Charge gets distributed. Since capacitance, I mean both having same capacitance, the value of capacitor same, in that case charge will be equally distributed. So final Finally, it will be like plus minus charge, that is CV naught, and here plus minus charge CV naught. So that net charge is 2CV naught. This is a shortcut. Even if you want, you can solve this mathematically as well. How you will solve? For that, you will take a potential, you will assume potential, common potential, V C equivalent, and then we'll apply this formula Q net is equal to C equivalent into V. So for that, you obtain V first and then obtain charge. So by using that, you will get same result. Or shortcut you can apply if capacitance are of same value, in that case, charge gets equally divided. So CV naught and CV naught. So now let's check options. The charge on the capacitor plate, upper plate of C1 is 2 CV naught. No, when we are connecting S2 now, what will happen? It is having CV naught charge. So correct option is B. Here, the charge on the upper plate of C1 is CV naught. Okay. Next, after some time, S2 is released and S3 is pressed. Now what we are doing is, we are releasing S2 and now we are connecting S3. Since the polarity of this voltage is, this is positive, this is negative now, so it will reverse the polarity of C2. Now the new polarity of C2 will be like plus and minus. What about charge? So charge is C into this voltage. Initial, it won't matter what is the charge on this C initially. Final charge will be C into V naught. So this is C into V naught. Okay, so the question is, the charge on the upper plate of C2 is 0. No, this cannot be answered. D. The charge on the upper plate of C2 is minus CV naught. Yes. Why minus C naught? Because lower plate is having positive charge, upper plate is having negative charge. So minus CV naught. So D is correct option. So if you have any doubt, you guys can ask any doubt in this particular question. So I hope things are clear. Now I'm ending today's session. So for further information, how Meritnation can help you, you can log into this where you can send your detail. Okay. All the very best for exam. In the next session, we'll take a few more questions of capacitor. Okay. Bye-bye. Take care.